looking at book will not help you in long term. Trust me. Try to understand. If you don't understand, ask question how to understand. Okay? Close all your books. Close all your books. I don't want to see any books open. Just tell based on what you learn. Anything. Try to recalibrate. This is just for you to get into the mood today. Okay?
How they are integrated?
How?
They are integrated.
What is that? Okay. We haven't go through. Did we go through that yesterday?
Biomechanics, sir.
Did we go through that yesterday? Never mind. Pass. Next.
What are the components that can be assessed in anterior view, and
Okay.
how
Sagittal
to
view.
collect data?
Okay. Very good.
How to use that fish app? How to use that fish?
Okay. No. Please. Everyone must share.
How did data?
How to collect data? Okay.
How did conduct the test?
The observations while testing.
Okay. The protocol, the test protocol.
Yes, sir. Yes, sir.
Game analysis.
Game analysis. Okay. Pass it to front. The four of them. Pass it in front.
Data analysis, we can compare the two videos, like we can check the improvement and all.
Okay.
Scope and importance of game analysis.
What is it? Speak louder.
Scope and importance of game analysis.
Scope points. Scope and importance. Okay.
A difference between optimal and the best.
Okay. Beside you.
The benefits of game analysis and the how to understand the angle of in the side view and how to track it.
Okay. Next. Just pass it in front.
Sir, about using two different cameras for front view and side view. We cannot
Okay.
use one camera.
Okay. The benefit of having two views instead of one view.
How to tracking
Auto
method.
tracking.
Biomechanics importance.
Okay. That is too general.
Performance analysis.
Specific on what you learned yesterday. That is the topic. You're talking about the topic. What did you learn?
The right and the wrong way of collection of data. The right way
Okay.
of collection. Recording of data.
Okay.
Document whatever we are doing.
Okay.
Setting up the camera positions.
Okay.
How to improve the performance in the sports and games.
How to improve?
How to improve the performance in the sports and
No,
games.
I say don't read what you wrote yesterday. What did you learn yesterday?
That
what-
is
Huh?
how to improve the performance.
So how do you improve?
Analyzing the views.
Okay.
Benefits of raw video data.
The
Raw video data. Videography, raw data. Benefits, how analyzing, using markers as well.
okay.
I understood about the squat movements, how to make the correction,
Technique correction.
technique correction.
How to capture up two-dimensional
Analysis.
analysis and athletes' movements.
Okay.
It focus on movement performance and 100% we cannot see the movement. We need tools to find out the 70% tools. Visual you can see 30%, sir.
Okay.
Angle positions of the subjects.
Position of the subjects during data collection or what?
Data collection.
During data collection.
Yesterday I learned about during the hopscotch.
Our body posture, proper body posture.
Okay. Proper body posture. Good. Okay. So, are we all into the mood now? You can recall what we learned yesterday. Today is just a continuation. We're going to do biomechanics also. What are the tools or equipments available in biomechanics? We're going to look into a bit of details on what are the terms commonly you hear in biomechanics, like kinetics. Those are the common terms that you cannot run away. Whichever journal you read, or in order to better understand and interpret, there are words, scientific words behind it. Okay, so understanding that will help you when you do analysis or reporting to provide quality report and understanding better. Okay. Do you all have any questions from yesterday? Any questions from yesterday? Anything you all don't understand? Because if you don't understand what we learned yesterday, we cannot move forward today. I don't want anyone to be in confusion state before we move forward. If you have anything, you can ask question. Okay? So we're going to look into type of assessment. What are the assessment? What are the assessment that we can conduct without much equipment? Very basic equipments which are available for you. And in advanced analysis, what are the type of advanced analysis available in biomechanical assessment? Okay. So biomechanical assessments involving evaluation of human movement to optimize performance. Our goal is always to optimize. Okay, our overall goal is always to optimize. So if you have something extra to do, more to do, that is not optimized yet, which means it's a continuous process. That is why we use the word optimize. It's a continuation process. To optimize performance and from preventing injury risk. Okay, combining those data from all the tests that we conduct. The purpose, there should be a purpose to conduct tests, first of all. Okay, we don't conduct tests because the coach asks you to conduct. We don't conduct tests because another of your colleagues is conducting the test, so I'm going to do that because he's doing that. No, you need to have a very clear objective in order to conduct the test. Mostly, we will do tests based on need analysis. If there's a need for that test to be conducted, we will conduct the test. Okay, to help the athletes understand their physical capabilities and their limitation, strength and weakness. Okay, there are certain tests that you can conduct without much equipment, such as you can do postural analysis, postural assessment. You need a bit of knowledge on what are the type of postural, type of body that is available. You can go and search online what are the type of body available. In this case, you can see 5 different type of body postures. Okay, so usually when we conduct this test, we'll try to minimize the clothes that they wear so that you can see the body posture when you're doing the test. It can be conducted from side view. Example, like in yesterday's practical session, there are certain important parameters that you can observe from sagittal view, side view. Okay, and there are certain important variables that you will get from frontal view. Okay, is there anything you can see differently if you see from front and behind? There's a camera from front, there's a camera from behind. What are the things that you can see from front that you cannot see from behind? And vice versa. Can anyone tell?
Behind, we cannot see the scapular, the lower angles, and the pelvic alignment, the scapular tuberosity, the buttock lining, and orbital fossa lining, and calcaneal angle at the position, the heel position, and the head symmetry. For that, easy to observe from the backside.
Behind posterior chain. Okay, if you want to look at the heel drop, it's better to see from behind. Pelvic drop, best to see from behind also rather than in front. So what other things that you can see from front but you cannot see from posterior view?
Front view, you can observe from the your ear loop to the shoulder height and the shoulder acromion process, alignment, nipple lining, navel alignment as well as your ASIS alignment and ischial tuberosity inside and then you have the knee angles, easy to observe from the front.
Okay, so good.
Patella,
Angle, okay, yep. So again, where you set your camera or your data collection protocol should based on your objective. That is why, okay, why we put on left or camera on right. There need to be specific objective for us to design our test protocol. So in this case, postural assessment, will there be anything different if you put camera on the left or camera on the right? If we are doing postural assessment. Why I see new faces? Y'all yesterday, did y'all hear? Are y'all here? Were y'all here yesterday? Any difference left and right? Yes. Which toward left or towards right? You can see from different view. Okay. So postural assessment, you need to have grid behind the, they call grid line to see the angle, to calculate the angle. Grid line, horizontal and vertical line. So you need to place here and then ask them to stand and then you can take picture from here. You can export it to Dartfish, Kinovia, whatever software, and then you can calculate the level in order to have objective data. Because when we are working with athlete regarding postural issues, we want to do some correction exercise. So you want to know whether they are improving or not, rather than just subjectively evaluate and give feedback. The best practice is to calculate in terms of angle, in terms of displacement. How far are they from their center axis to left, right, front, back, and then after correction exercise, after maybe 4 weeks, 6 weeks, do another assessment with the same set of protocol, same distance, and then calculate back. And then you will see how much of improvements are there. Okay? Functional FMS. Any FMS, anyone done FMS before? Okay. So I think you need to have certified, right? To do this? Okay. Okay. There are 7 type of exercises for you to conduct. If you can learn from someone who's certified, actually, if it's not actually you need to have certificate for that. You need to be certified. You can go for the course. If not, if you can do for your own athletes, there are a lot of available resources to learn how to do functional movement screen. So it will give you ideas on which joint have tightness, the flexibility of that joint. Okay, how about balance, upper body, lower body. Okay, it's called FMS screening, functional movement screening. You don't need much tools or technologies to do that, just the knowledge of how to conduct the test and reporting. The scale is, how do you scale that? So there are scales you give. So it's still subjective, but it will get the job done. Okay, if there's a bigger compensation or issues with muscle tightness, you can capture here. You don't need specialized tools to do that. If you have, that is better. If you don't have, you can move with this screening process. Okay. So apart from this, any other assessment that you think you can do to understand posture of someone? That yo-yo test, you have Y balance test. There are multiple tests. I'm sticking to this because we are focusing on functional movement of biomechanics. In terms of biomechanics, if you want to go into physical, there are plenty of tests that you can do. Okay, this relates because this will have effects on their movement, for sports-specific movements. That is why I put this as example, because this posture will have issue. If you ask this guy to run on treadmill, you will see improper gait. So without correcting this, we cannot ask them to change their running gait. So you work from here and then move into running. Those are the set of testing that we do in biomechanics. Same goes to hip functional movement. Mostly when you are doing squat, you'll know how rigid is their, how tight is their hip muscles. You will understand from this test. Okay, some of tools available to conduct biomechanical assessments. Okay, I will go through a few of the tests that we have, such as force plates. We have motion capture system. Motion capture system will capture 3D humans motion in 3 dimension. Okay, what we did yesterday is 2D, 2 dimension. So the difference between 2 dimension and 3 dimension is you cannot see one movement you cannot see. Example, if I'm standing here, if you're capturing data from in front in 2 dimension, you can see my height. You can measure my height. You can measure my shoulder width. You cannot measure my depth. How thick is my body? You cannot measure from 2D. Understand? Okay? If 3 dimension, you will be able to measure my height, my width, all 3 axes, X, Y, and Z. In this case, if I jump, you can measure my jumping height using 2D. If I move to the right, you can measure the displacement of my body. But if I move behind, with 2-dimensional, you cannot measure what is the distance I move behind. That is the limitation between 2 dimension and 3 dimension. So the limitation with 2 dimension is, you are limited with 2, X and Y, or Z. Okay, so by using motion capture system, anyone applied motion capture? Have used, experienced motion capture system here? What are the system? Vicon, right? Vicon?
Virtual reality led you there.
Virtual?
Virtual reality. Capture the movements also.
No, what brand? Accents or what brand is that? That's okay. Who? Vicon also, okay. So actually there are a lot of brands available, but all brands going to give you the same type of outcome. Okay, the working principle.
That camera that it captures the movements for that AI.
The
That camera, that AI camera stuff.
AI cameras, yes. There are even 2D cameras will convert you into 3D, but still there are questions on the reliability. How reliable is it? Yes. So can you speak loud? Any extra microphone? That there are a lot of questions.
Last year you were conducted here Karnataka State Yogasana competition. There you used 3D, sir. 3D you were putting their cameras here starting the yoga competition. There is completely 3D. Just it's trail. AI tool is using. In future it is help to analyze the how to do the completely AI tool is using.
For yoga pose, is it?
Yoga competition.
Yoga competition.
Yes, yoga.
So in Japan 2020 Olympics, they use 3D motion system to evaluate. For a trial they did for gymnastic actually.
Yes, because all the competition it is in future it will become.
Whatever subjective sports, such as synchronized diving, diving is still subjectively evaluated. Gymnastic, all this they are moving towards using 3-dimensional combination with AI, so that they set the criteria for scoring. Example, if I spin 360 degree, I'll get 2 points. 540 degrees, I'll get 3 points. So they'll set the criteria in AI, and then the AI will give you the score by using motion capture system. Okay, I think in Tokyo Olympics, they use around 100 cameras around the hall to capture all the movement for the sports. Okay, so this is how typically 3D analysis will look like. So the process of collecting three-dimensional analysis, I think the principle behind is we call that as a DLT method. Okay, DLT method is the principle behind how it capture. For example, you want to know the movement in space. Okay, movement in space, you need to understand the space in 3 dimensions. So the direct linear transformation, meaning that if you would mark, there's a marker they will use to place, and then the position of the marker changes in the position will taken into the formula behind the script. Okay, I will explain about it further after these slides. Okay, this data we call as tech trainer. Tech trainer give you an information on how much of force production or power production for functional movements. So it's a machine where it will be connected with a type of like wire, where when you push, it will give you the peak force for any functional movement. You can use it for upper body or you can use it for lower body, anything, called as tech trainer. This is EMG quality setup which we use for 3D motion analysis. EMG, this is the tech trainer I mentioned. So they can combine multiple devices together to synchronize and capture the data at once. Okay. For example, this is typically our setup in the National Sports Institute, what we have. So we have force plates here. You can see these force plates that we have. These are force plates. Okay. So these are the cameras, motion analysis. We have 25 Qualisys cameras available to capture the data. And this is one of the tests we did with badminton athletes. Okay. So there are sensors, what we call as optical sensors, which reflect only into the optical sensors, infrared cameras we call. So the markers that we place, if you can see the markers placed, and the cameras can only detect the markers placed at the skin on the joint and capture that, and we'll convert it into stick figures. But there are also markerless system available in market. Okay, markerless system where they use AI-based tracking, like some mentioned. There are a lot of AI tools available there for you to get 3-dimensional data using 2D. Okay, there are a lot of free applications available also, but I'm not sure about how reliable is those data. Okay, because when the gold standard to capture 3-dimensional data is motion capture system. That is the gold standard. Okay. So when do we use this? When do we use 3D motion analysis? So can anyone give me some example when do you must use 3-dimension analysis instead of 2-dimension? Gymnastics. Why do you need 3D and not 2D? You can ask them to do and record from camera. You can calculate how many times they rotate. Okay. The most important thing why we need this, to measure kinetic of the movement. What is kinematic? What is kinetic? We'll see later. Which means how much loading acting on the joint. I'm throwing a ball. Okay, you can calculate my shoulder angle, you can calculate my elbow angle, you can calculate the release height, you can calculate the release speed. But can you calculate how much of torque going through my elbow when I'm throwing? You cannot. Unless you have this system. Three-dimensional data. Okay? We can use this for rehabilitation monitoring. Usually we'll do walking gait analysis for post ACL reconstruction athletes to see how well they are recovering back and are they ready for return to play, RTP. So that is from clinical perspective. In performance perspective, we will look into any movements, whether it's kicking, throwing, jumping, even in martial art, what is the speed of that action, any performance related, and then from there we will look into the sequence of the movement and give some technique correction. Okay, force plates. Force plate is a tool or device made out of four sensors at the edge of the plate. There are two types of sensors. One is capacitive sensor and piezoelectric sensors. Okay, there are different brands available now. Now they have this. Depends on how many axes you want to look into, how many degree of freedom you are planning to look into. Okay, so it measures ground reaction force during activities, any activities, jumping, walking, running, and provide data on force, magnitude, and the timing of how fast you have contact with the force plate. Some of the assessment that we conduct with force plates are like balance assessment. If you are we all aware of sway analysis, sway data. Sway data is to see how much how good is someone's balance with single leg. Usually we'll try with single leg balance to see how much sway happening. Sway means how much their body is moving left, right, front, posterior, anterior, posterior, and sagittal, what is that, left and right? Lateral, medial lateral movement. Okay, medial lateral movement. So there are certain protocols to check on sway analysis. So why do we do this? Why do we do sway analysis? Is because one is to understand which joints help them to support more in terms of balance, and to understand the proprioception of that individual, which means there are tests that we do with open eyes and closed eyes. So how we are balancing ourselves now when we are standing or moving is by the sensory input that we have. That is why if you see people who's partially blind or blind, they will depend on some other sensory system. Kinesthetic sensory, which is touch. They know how to move because they don't have visual input. People who have good visual without any issues, it depends on the visual input, which automatically send information to our body to avoid. If you see a surface which is uneven surface, you know how to walk, how your body adjusts to it. It's all based on the previous data which is stored inside your system. Okay? So that is why we use force plates to measure balance, how good. So we have different protocols to measure balance or sway. So usually what we will do is we will ask them to stand with single leg, and we'll record for 30 seconds by looking in front. And then we'll second test the same leg. We'll ask them to close their eyes. We put the blind and then ask them to stand without looking, with closed eyes. So you compare this with and without, with open eyes and closed eyes, you will get the difference between how good is your proprioception. The sensory system help them to balance themselves, static balance. There are also protocols for dynamic balance. You can use force plates to do dynamic balance tests. Some dynamic balance, while standing like this, they move down, touch, and then they come back. So you'll know how good is their dynamic balance in that case. And you can compare right and left. And you can, from there, using the data collected, we can design an intervention training. For that, if you know that you want to improve, if you have a normative values, that is good. Depends on sports, how well or how important is this balance for that sport. Okay, example, like skill sports, mostly shooting, archery, it's important for them to have a good balance between left and right. For them to have good balance and endurance. Balance, you need endurance also, because it's a very, time consuming sports. 60 shots, 100 shots. So depends on the test that we conduct, we'll go back to need analysis. Do they need the test or they don't? If a sport which doesn't require this assessment, we don't do it. We stick to what do we need. Okay, if you go back to what do we want everything. We don't do that. We stick to what do we need. There are a few example brands available. Kistler, we have Kistler. Before this, we use AMTI. Okay, and Bertec. Any questions until here? Any questions? Can we use force? Yes. We use piezoelectric sensor. That gives us, it's small and light, and the accuracy wise also, because you are using humans and not rigid body to test. It's, if for mechanical means capacity is robust. If engineering, anything to measure, to do with engineering, we use capacitive sensor, because it's robust compared to a piezoelectric sensor. Because human movement is maybe 5 times or 7 times, it can go up to 5,000 Newton. So we prefer to have that. Can we use force plate alone without combining motion analysis? Can. You can. Okay. So you can combine motion analysis. You can combine force plate into motion analysis to look into kinetic, what's happening inside and what's happening outside. Okay, now we can combine EMG, electromyography, together. You can combine EMG, you can combine force plate and motion analysis together. You can even combine, there's a glass where it will look at where are your gaze, to look at your gaze, where are you gazing before you do certain action. Okay, EMG, we will have hands-on experience. Okay, we are lucky that Mangalore University Physical Department Education, they have a set of EMG here. So we're going to experience this. So anyone who have experience using it, you can try it today. If you don't have experience using EMG, then you can observe and learn from it. Okay, so what can we get from here? It measures electrical activity of your muscle movement. Okay, it measures your signal in your muscle. So it gives you a pattern and activation of your muscle. So meaning that if I'm using that muscle for that phase, let's say I'm walking. Now in this case, my tibialis anterior is at the highest position. Okay, and when I'm pushing, my gastroc is at the high position. Same goes to tibial. So with left and right, are they firing? Are they working, activated at the same magnitude? Let's say if my left provides 10 millivolt and my right is giving only 8 millivolts, so we know that it's not activating at the same magnitude, same amount. So from there we know whether my left leg is over activated unnecessarily, which it doesn't need to activate that much. We won't know, we cannot get this information unless you use EMG. Okay, unless you use EMG, we cannot. Sir, if you want to speak on your phone, please go out and speak. I've set our housekeeping rules yesterday. You're distracting the class. Okay. Where was I? Yes, unless you have unless you fix this EMG in those muscles that involved in that movement, we won't know that information. We won't get the information. Okay? Okay. Can we recap back what we learned from today morning? Just anyone randomly recall back what we learned from today morning. I think 6 or 7 slides, right? 6 or 7 slides. Okay. Difference between 2D and 3D analysis. What else? What is that? Okay. Difference between 2-dimensional and 3-dimensional. What else? Motion capture system. What is it? Tools for analyzing. What are the tools available? FMS. Okay. Functional movement screening. What is that? Okay. Postural analysis.
Through your experience, you work with elite athletes, right? So, at the beginning of an athlete's journey, posture analysis, can you determine that this athlete would be a very good athlete later on?
Okay. Through what we can do from the screening, if we call pre-season screening, or anyone new recruit joining national team, we have a certain assessment protocol. We'll do certain assessment like walking gait, running gait, isokinetic test, few tests to have their profile when they are newly joining. Why do we need that? Because in case if they had any injury and we don't know how their normative values, to get the normative values from them, how do they walk, we don't know. If their normal walking gait is in that such way, when they're injured, we know what is the difference between the injured and before they're injured. So coming back to the questions, can we predict whether they will be good with that sport? No, we can't. But can we identify the posture and correct it so that they can perform better and we can reduce the risk of injury? Yes. Because posture plays an important role when you're doing any movement. How much of load, weight you're putting on your knee joint, your hip joint, when you're doing any movement, the posture plays a very important role.
In specific sports, you need the body to adapt in specific ways. So every sport will have their own kind of posture. So in hockey, they have commonly.
Yep.
If you have taekwondo or other things, hips are in a certain way. How much can we allow for the posture to vary from our ideal normal posture, so that we can have just an eye out for it? Like, okay, this is going too much. Just take care of this. How much is the range?
Okay, who don't understand the question? Okay, you don't understand. So the question is, I'll repeat the question. So that, okay, the question is, there are certain movements when you do that for repetitively for long duration of time in your athlete's career, there will be some postural modification happen due to that demand for that sport. Example, hockey. If you're a right-hand player and you're doing this position every day for 10 years, you can see a bit of drop on your right shoulder. Okay, you will see that drop on your right shoulder. Any sports with jumping and landing, like wushu athletes, if you look at them, you can say board leg. Because of the impact, every time they do somersault, they land, jump, land, multiple landing per day, per week, per month, and years. High impact movement. Even though there are platforms which can absorb certain amount of force, but still you can see the body different than. So usually now if I look at an athlete, 80% I can tell what sports do they play. Seasoned athletes, because of their posture. That is the question. So can we allow that certain amount of postural change? Can we allow? Okay, go back to if that makes any disadvantage for the sports, or that is not helping that sport. Example, if hockey shoulder, when your shoulder switch, your center of gravity will switch. When your center of gravity switch, you will tend to put load on one side more than your opposite side. Then in long term, the high chances that you'll have knee injury, mostly low back injury. You'll have low back injury in 5, 6 years, 7 years. In your 7th year you join, you'll have that. If you don't do this postural correction at the beginning. And corrective exercise. Don't only train left, you train your right. If you're using right, train your left also. If you cannot ask them to go and play hockey in the left, you cannot do that. But there are certain exercises you can integrate along with their strength and conditioning training to compensate that, to make sure that they don't have that effect because of the training. Okay, so when you do need analysis, what do we need? This is one part of need analysis. Okay, what movement they do repetitively, which cause them to have this compensation on one side. Any other questions before we move on? Ankle? Angle. No, angle is kinematics. Angle you cannot measure because this only give you force from the ground reaction force. This is not to measure strength, this is to measure the force. Strength, we'll have another test after this. Isokinetic dynamometer. Okay, force plate will only give how much of force you are applying. If I'm standing here, what is the amount of force I'm applying? What is the amount of force I'm doing? How many Newton am I applying now? My body weight times into gravity. 9.81. Okay, if I'm 80 kilogram, 80 times, if let's say I'm 100 kilogram, my force will show, if I'm standing on top of a force plate, it will show what? Around 1000. 9.81, if you round it to 10, it will show 1000 Newton. If I'm standing on the screen, it will show 1000 Newton. So if I'm standing with one leg, 500 Newton, will it show 500 Newton? No, still 1000 Newton, because you cannot change this. Okay, if I have two force plates, I'm standing, how much will it show here? Two force plates. If I'm standing on top of two force plates, how much force will be here? How much force will be here? Total 1000 Newton. Huh? No, no, it will show 500 and 500 because my weight has been distributed into two force plates. So when we do sway analysis, sway analysis using force plate, this is one of the components when we look at. If he's standing straight without doing anything, is he biased towards one side or not? Mostly they will bias towards their dominant side. If I'm a right legger, I'm strong with my right leg, I'll tend to have this natural way. We do open eyes and close eyes also actually. It will give you a lot of information. Just standing there, recording them standing for 30 seconds for 3 trials with open eyes and closed eyes on top of force plates will give you a lot of information about that. Whether the sway happen in front or back or left and right, you can see, you can understand the chain of activation happening when they're standing. Where is their strength, where is their weakness, you can tell from that. Is there change? Yep. Depends on the weight and gravitational. Usually if I'm standing and jumping, I'll get 3 times my body weight or 4 times, depends on how much of force I generate. to jump. If I'm strong, if my lower body explosive power is good, I can jump higher. When I land, the force production will be greater, 3 times, 4 times of my body weight.
Andrew Flintoff. Had a lot of mental was analyzed that when he jumped to the lead home, the impact on his landing was 9.9 times the body weight. So, will it, what max, till what maximum can the...
Is the microphone? Why is the microphone? What?
When he lands on his feet, it was like 9 times his body weight. The impact was around 9 times the body weight.
9 times is very high. I've never seen anyone can do 9 times. Maybe I've never seen such strong athletes.
Yeah, because that's what I just happened to see an article on that. That's why
9 times body weight.
Yeah, because he was very huge in build and thing. That's the reason why he used to.
Even huge, we are normalizing to their body weight. So size doesn't matter there when you normalize to body weight.
Okay, up till what times the impact would be for a normal person, for an athlete?
No, it depends. Like I said, depends on how much of force you are applying. Depends on how much strong you are. That is how the measurement will become. So that is one way we measure lower body explosive power. How good I'm improving in terms of my lower body explosive power can be measured with force plate. So when I go down and I start to jump, so it will give me information on my concentric force, concentric strength, how much I'm going. When I land, this will be a peak graph. Like you said, 3 times, 4 times, or 9 times body weight. Landing, there'll be a peak graph, and how fast I recover to go back to my normal weight shows your eccentric strength there. RFD, they call rate of force development. And when you land, how fast you recover from that. Lot of information. You see? Okay. Okay, a lot of information can be gathered. We use this for all clinical assessment, performance assessment, like injured athletes, ankle injured athletes. There are certain protocols that we do. Ankle injured athletes. Example, drop jump. From 30 centimeters, the protocol we said is 30 centimeters, they'll stand there. And then they just from here, they just line like this. From here, they just line like this. With one leg. And then how compare injured leg and non-injured leg. How much of force they generate, how fast they recover the eccentric force. We can understand from that. Okay? So if you don't have, yes.
Landing. Sometimes the athletes who are still stiff landing.
Yep.
Like they will not bend the knees properly. Some are they will do soft landing. They will just squat out. So where is the sweet spot? How much of the squat should be allowed after landing? How much beat should I allow?
Okay, there are different protocols out there. Some say stiff landing is good to see certain parameters. Some say you let them go down and jump again. From here you land. Sorry, I cannot jump from there. I can show from here. Okay, I land, then I jump and land again. So different set of protocols based on what do we want to see.
There are parameters.
Yes, yes. But usually we don't encourage stiff landing for clinical athletes. For performance-wise, yes. If you want to look into performance, they're healthy, you can ask them to do if required. If required. So different set of protocols for different objective. Remember, always go to the objective of that assessment. We don't do assessment because we have that. I have force plate, I'm going to do that because I have force plate. No, it doesn't work like that. Okay? Any other questions? One?
Training method is there. It's called depth jump. Depth jump.
So in depth jump, it's recommended to go for 120 degree of knee angle after landing to the ground. Is that okay? So it's like
What is the purpose of this jump?
to develop explosive strength.
To train or to test?
To train.
To train what? What are we trying to train here?
To develop explosive strength of an athlete.
So concentric force.
Yeah.
You're talking about concentric
Yeah, yeah.
force. 120 meaning what?
120 degree of knee angle. Knee angle. See, once you jump down.
This is 90.
Yeah.
So it lower than that.
No, it should be upper than that. Like that.
Oh, so this is 180.
120 they recommend.
So if I'm standing, it's 180.
Okay, that's one
It's 180.
180,
Yeah?
180.
Okay, 180, which means I go 60 degree
Yeah.
flexion.
120 degree I said.
Okay, if you reverse it, it's 120. Let's say, because we normalize 0 from here.
Okay, fine.
Okay, so 120. What is the reason?
To develop what I said, explosive strength.
Okay, I think I mentioned this yesterday about which muscle generate peak force at which angle. So like I said, in order to jump, your glutes, your hamstring, your quadricep muscles plays an important role. Okay, of course your ankle, tibialis and gastroc plays a role during the chain of movement. But when you go down 120, 60, 120, okay, you're not activating certain muscles which will activate below that range. Because if you go 80 to 90, that's why we do squat at 90 degree. Because that is where the highest concentration activation happen at your VMO and VLO. So if you limit your range of motion there, you're focusing mostly on hip and not your knee. Because your hip is at that range of motion, you're training your hip muscles to explode for power training. So go back and look into at which range of motion, which muscle will activate at the peak, and you train from that. So you can also measure this specific muscle, which muscle activates at which
angle,
range of motion, using isokinetic dynamometer. This machine. This is my research assistant during my study. Okay, so we were measuring shoulder internal and external rotation. Why do we measure this? Coming back to your question, which if I want to smash faster, if I want to generate greater smash, at which angle should I train their internal rotation training? Because we do internal external rotation training for badminton, because shoulder plays an important role, one of the important role in order to generate. So do we train from here to here, or here to here, or here to here? So this is the graph that will tell us the peak torque happen at which range of motion. By understanding, and then the kinematic results, the lab results will give us the angular velocity movement. The speed of the movement, it will happen before contact. It's around 70 to 90 degree is where the sweet spot of the maximum range of motion. Maximum speed of racket production at that. So this data, we take our shoulder angular velocity data where the maximal speed happen, and we take isokinetic data. If they are early activating, we modify the training accordingly. We don't want them to have peak force here. We want them to have peak force here. So whatever training that we do, we will adjust or modify the training so that they'll generate this peak force at the range of motion that required for the sports.
Peak force production, will it vary from individual to individual?
Yes. Yes. Mostly if they've been playing that sport, it will be close, very close. If someone comes from different coaching background, some coach prefer to train from young in a different way, another coach will train to, some group will have strength and conditioning combined with sport specific. Some will not have that, some will fully depend on core training or specific. Football means they only do football, they don't do strength and conditioning. So that is the advantage of this sport science, existence of sport science, to understand better on the movement, functional movement, specific movement, and then we measure it using those tools available and then relate it to each other. We relate from the machine and this machine, and we understand the movement, and then we know what can help them to do better, perform better.
Same sport, same skill, peak force generation will be different from sports.
The amplitude will be different, even though same height, same weight, the muscle types is different. Some will have longer head for that muscle based on because of their body type. Some will have shorter, some will have different type of fibers, greater, the combination of muscle switch type, fast twitch, slow twitch fibers. So it will be different.
The anthropometry also play a vital role.
Yes. Yes, it does. But like I said, they won't. If not everyone will peak at 20-30%. If 60 to 63, another person is 65 to maybe 70, the peak force is there. Within that range, but we'll try to switch it to the best range of motion where it should be, according to the sports demand. Because after this, before this, it's against the gravity. I'm pulling against the gravity. Understand, this is gravity pull me behind, right? Against the gravity. So the amount of force my muscle is generating is greater because I'm doing something against the gravity. After this movement, I go towards gravity. The gravity takes place. So how can I apply greater force here? I'm not using the advantage of gravity here. Understand or not? If I'm pulling something from behind, let's say I'm holding weight, let's say this is 10 kilogram. If I'm pulling this against gravity, it is required for me to apply more force. Compared to from here, I'm pushing it down. I have advantage of gravitational pull. So why do I want to use all my energy at here? After this, I don't have maximal force to produce, and I depend on a certain amount of force and gravity. I should have peak force here along with gravitational pull to generate maximum output. Yes, yes. That is what it should be. That is what it should be.
In case of rapid sports, when you measure the peak, that will tell you what time you should contact.
Yes. So in my study, I will share my study. Not today, I think day 4, I will share my studies. And I have another study to share with you all also using equipments. So where is we call sweet spot? Where should be the contact happen? And at which range of motion? And what would be the elbow angle during that motion? And why is that? Everything. That is my study, one of the study. Okay? We'll move on. So this is example of gait analysis. Anyone done gait analysis here? Walking gait, running gait? Both? Both, okay. So we will do one walking gait today. End of our today's practical session. We will use that treadmills. We'll put behind. We'll divide into groups, like similar group as yesterday. Okay, we'll do 2 walking gait, 1 walking gait, 1 running gait. So later I will go through some theoretical on the phases of gait first. What are the events of interest when you're walking? And then you come out with your own set of protocol to record, as I mentioned earlier yesterday. You create a protocol, you record, and then you transfer it into your laptop, and I will tell what are we going to look at it. Okay? So you can see this walking. So the red color line, if you can see, is what we call as ground reaction force from the force plate. Okay, when someone step on the force plate, there will be some ground reaction force from force plate, and sample of knee angle. So usually with the system that I use here, we call this, I use Quality system. Okay, Quality system, which integrated with third-party software, which is Visual 3D. Qualysys is for me to capture the data, three-dimensional data. I will export it into Visual 3D to process it, to clean the data, and to get the results out. So this is one of the results we can see. Okay, within that system, there will be some normative values, some norms. This is how it should be. This is the angle it should be during this motion. During hip should be in what range of motion during this swinging phase. There are some normative values. You can see the gray color here. The gray color is the range where it should be. Okay, that's called normative values. The norms that it should be every action. Okay, so the different color, different graph is different during different speed of running. So we can see if I increase the speed of running, is there change in this knee angle, flexion, extension? Okay, right, knee abduction, adduction, is there any angle? And then from here we know, okay, the knee is collapsing inward when he's running, when the speed is increasing. And then we until here we will report the corrective exercise. We will give let the physios handle. Usually the physios and us work very closely, hands on hand. Okay, mostly we depend on physios actually. Biomechanics, we depend on physios to do all this for us. Data collection we do as a biomechanist. Data interpretation we will do. Exercise suggestion we will let the physios handle because they know the best. Certain, if it's a specific movement, we will do the intervention. Any specific movement like volleyball, football, specific movement, we know which muscles required for that specific movement. We will recommend along with the strength and conditioning. When it comes to performance, we are talking about performance. Clinical, we'll pass it to physio. Physio will see this, will explain to physio, and then physio will work on improving this part. Left knee abduction. Positive is adduction, negative is adduction. Okay, so it's coming towards inward. So from here, they will do 4 to 6 weeks of intervention to specific training, and then we'll retest again. We'll do another test, and then we'll compare. We can compare the data from previous